welcome back to the final round of the Funky Physicist Game Show. We are here with our final contestant. The final question is, which egg will break? A raw egg thrown at a loosely hanging sheet, or a raw egg thrown at a taut sheet? On your marks, get set.
What's the answer? I remember doing these experiments before. They explain momentum and impulse.
Pause. Quick physics review. Momentum is a measure of an object's motion. It is represented by P in the equation P equals m times v, or momentum equals mass times velocity. Impulse is a change in momentum. From Newton's second law, the impulse-momentum equation is force times time equals mass times change in velocity. When applied to these experiments, since both the mass and the change in velocity of the egg are constant, the right side of the impulse-momentum equation will remain constant. We'll henceforth represent the right side of the equation as c. In the first experiment, the time it takes the sheet to slow the egg down is very large, meaning that the average force exerted on the egg by the sheet must be small. Therefore, the egg will not break because that small force is smaller than the average force it takes to break the egg. Let's try this with some numbers. We used momentum-impulse equation and researched average values for mass and velocity.
But the time in this equation is going to be really big, or about 0.5 seconds. You get force equals 3.06 newtons, which is a lot smaller than the 25 newtons required to break the egg.
In the second experiment, the taut sheet slows down the egg quickly, so the time variable is very small, meaning the average force exerted on the egg by the sheet must be very large to get the same value for c as in the previous experiment. This large force is larger than the average force it takes to break an egg, thus the egg breaks upon impact.
So you have the same impulse-momentum equation, and since the mass and the change in velocity of the egg stay the same, it's still going to be 1.53 kilograms times meters per second on the right side. However, this time the time is going to be a lot smaller. The sheet slows down the egg in about 1/100th of a second, so you get a force to be 153 newtons, which is much larger than the 25 newtons necessary to break the egg.
This can also be explained by work.
Okay. So the equation for work is work equals force times distance. However, there's another way we need to get work, which is the change in kinetic energy, which is equal to 1/2 mv squared. We're going to use the same values as in the last few equations. You get work equals 20.5 joules. We're going to plug that back into the work equation, and this time plug in a distance to try to find a force. The distance, when you throw it against a hanging sheet, is pretty big, 1 meter. You're going to get the force to be 20.5 newtons, which is less than the 25 required to break the egg. This time we're going to use the same equation. So the left side, the work is going to stay the same. This time the distance is going to change. When you throw it against a taut sheet, the distance is very small, about 1 centimeter. So this time when you calculate the force is going to be much bigger, 2,050 newtons, which is more than enough to break the egg at 25 newtons.
Go!
A raw egg hitting a taut sheet will break. And we have a winner!